Hello, welcome again to the lecture series on Control Systems Engineering. In this session, we'll study about signal flow graphs. Here, we will define signal flow graph and associated terminology. Then, we'll find transfer function of a given signal flow graph using Mason's gain formula. Then we'll draw signal flow graphs for a given set of relationships or block diagrams and obtain transfer function. So it's another method of finding out transfer function. Here again, if you have a complex system, a set of equations can be written. From those equations, we can create the signal flow graph. From the signal flow graph, we can use Mason's gain formula and we can determine the transfer function. Okay, right. So let us define terminology. So basically in a signal flow graph, we represent the signal by a node. Okay, U of S is a signal, an input signal, a node. Let us say Y of S is a signal, a node. So signals are represented by nodes like this. And transfer function is represented by a branch. So this is a branch. This is a node. Okay. So suppose, let us say we have a simple control system like this. Here, as I mentioned, this is a reference signal, error signal, controlled variable. Of course, you can have feedback signal here. So here, R of S is a signal, so a node. Then E of S is a signal, a node. C of S is a signal, a node. Right? Now let me join R of S by R of S to E of S by a branch. There is no gain, I'll just write it as 1. Then E of S to C of S, let me draw another branch. The gain is G of S. Again C of S to E of S, I'll join by another branch. So the gain is, this minus sign is there, so minus H of S I'll write. If you want, you can extend this, and once again you can draw with a gain, a branch with a gain of 1, and again you represent this as C of S, just to satisfy the definition of. Later I call this node as a source node, and this I call it as a sink node. Okay, so source node is a node for which signals flow only away from the node. So you just take node, whatever the number of signals that are leaving, you can mark like this. Such a node, we call it as a source node. Sink node means, suppose if you have a node, all branches should come and meet like this. That's a sink node. This is a source node. This is a sink node. A path is a continuous connection of branches from one node to another with all arrowheads in the same direction. That is, all signals flow in the same direction from the first node to the second. So this one, start here, go in this direction, this becomes a forward path. Okay. Loop. You start from a point, move in the direction of the arrow, and come back to the same point. That becomes a loop. but you should not cross any node more than once. A loop is a closed path in which no node is encountered more than once. That's very important. Should not cross any node more than once. Okay. Right. So forward path is set. Then path gain. Suppose you take this path. The branch gain is 1. Here the branch gain is g of s, or transfer function is g of s. Again, branch transfer function or gain is 1. So 1 into g of s into 1. That is what I call it as path gain. The path gain is the product of all the transfer functions of all branches that form the path. Loop gain is the product of the transfer function of all the branches that form the loop. Again, go back to this. So this is the loop. Start here. G of s minus h of s. That is the loop gain. Correct. And non-touching loops. Two loops are non-touching if these loops have no nodes in common. A loop and a path are non-touching if they have no nodes in common. Means suppose you have a forward path, let us say, or this is one loop. Okay, this is right. Then you have one more node here and one more node here. And you go like this, come back. These two loops are non-touching loops. They are not sharing a common node. Two loops are non-touching if they have no nodes in common. Okay, right. So these are the definitions you should have, right? So let me tell you once again. Source node, 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 node. These are signals. Branch, branch, branch is also a branch. So branch transfer function, branch transfer function, branch transfer function, or branch gain, branch transfer function. Start here, move in the direction of the arrow, and without crossing any node more than once, reach to this point. That is forward path. Multiply all the transfer function. 1 g of s 1. That is forward path gain. Start from a point, move in the direction of the arrow, and come back to the same point without crossing any node more than once. That is a loop. This branch transfer function you multiply, then you get the loop gain. And also I have told you non-touching loops. Two loops are non-touching if they do not share a common node. These are the terminologies that we normally use. This is what we call it as basals gain formula. This is given by t is equal to, that is transfer function equal to 1 by delta sigma k equal to 1 to n pk p suffix k delta suffix k. K stands for index for the forward paths. N is the number of forward paths. If there are n is equal to 3, then it is P1 delta 1 plus P2 delta 2 plus P3 delta 3. Okay, P1 is the path gain of the first forward path. Similarly, P2 is the path gain of the second forward path. P3 is the path gain of the third forward path, like this. Correct? Then what is delta? Delta is given like this. 1 minus sum of loop gains of individual loops. Identify all individual loops and get their loop gains. Then plus sum of product of loop gains of all possible combinations of two non-touching loops. Okay. Next, minus same sum of product of loop gains of all possible combinations of 3 non-touching loops, 4 non-touching, like that. You should go on doing it. So I told you pk means path gain of the kth forward part. Delta suffix k, it is the value of delta for that part of the graph not touching the kth forward path. So if you understand this, then if you substitute, you will get the transfer function. So once I solve one simple example, you will understand the meaning of all this and how to find delta and delta k. So now the example is this. Draw a signal flow graph for the following set of equations and obtain the transfer function. They are given 1, 2, 3, 4 equations. You can clearly see that how many signals are there. x1, x2, x3, x4, x5. Okay, there are 5 signals. So there should be 5 nodes. Mark 1, 2, 3, 4, 5. Call it as x1, x2, x3, x4 and x5. Okay. Now after marking, first identify the number of signals, and so many nodes you mark. Now let us look at equation 1. What it says, x1 multiplied by a12 must be equal to x2. x1 to x2 you draw a line and the path gain is a12. Correct? Then x3 multiplied by 3 to x2, x3 to x2. This is x3, x3 to x2. Go like this. Feedback path. The gain is a32. Then x4 to x2, x4 to x2. Draw like this, a42. x5 to x2. Okay, a52. You got this. Let us look at second equation, x2 to x3. The gain is how much? a23. Next, x3 to x4, x3 to x4. What is the gain? a34. Next, x4 to x4 itself, x4 to x4 itself. This is say a44. Next, x3 to x5, x3 to x3 to x5. This gain is a35. Next, x4 to x5. The gain is a45. Okay. Here is a sync node. So just to have a clarity, introduce, and once again you call it as x5. Okay, this becomes the source node, this becomes the sync node, output node. Now we have drawn the signal flow graph. That's what I have shown here also. So this is how you have to draw the signal flow graph. Now you have to find the transfer function. So you know that delta is equal to, t is equal to 1 by delta, then sigma, k is equal to 1 to n, then p suffix k delta suffix k. Correct? Now number of forward paths. How many forward paths are there? See here, I start at this point, carefully trace. There is one forward path. Correct? Next, start here, go like this, take a deviation like this, go like this. This is second forward path. Both the cases I am not touching any node more than once. Suppose let us say this color I'll choose. Start here, go like this, come back, go like this. This cannot be a forward path. Reason is we are touching this node twice. Thus there are two forward paths. Since there are two forward paths, T should be 1 by delta P1 k is equal to 1 means P1 delta 1 plus P2 delta 2. Correct? So this is our Mason's formula. Now find P1, P2, delta 1, delta 2, delta and substitute, you will get the transfer function. So what is P1? Okay, what's P1? P1 is equal to, look here, A12, A23, A34, A45. So product of path gains, A12, A23, A34, A45 into 1. Next P2, path gain of the second forward path. A12, A23, A35 into 1. So you have got P1 value, you have got P2 value. Next thing is you have to find delta. 1 minus sum of loop gains of all possible combinations of sum of loop gains of individual loops. Let us identify loops. This is one loop. Call it as L1. Start here, go like this, come back like this. This is loop 2. Start here, go like this, come back. That is loop 3. Start here, go like this and come back. Say loop 4. Start here like this, follow this path, come back like this. That is loop 5. Okay, we do not have any more loops. I have identified all these things. So it is L1, L2, L3, L4 and L5. Okay, plus consider two non-touching loops. How many such combinations we have? So finding color, let me choose green color. Okay. This loop you consider and this loop you consider. These two are not touching. So L1 and L4 are not touching. Next you consider this loop. And then you consider this loop. So L4 and what is that? L5 are not touching. So you just find out any other two non-touching loops are there. Suppose if I take this loop and this loop, these two are touching here. So I don't think any more two non-touching loops are there. Next we have a three non-touching loop. If you search for three non-touching loops, correct? I don't think you find any of them. So 0. Now substitute the loop gains here. You will get delta. Next, let us find delta 1. It is that part of the day. It is that part of delta which is not touching the given forward path. So you take this forward path. You can see that all loops are touching this forward path. So this part will become 0. So it is simply 1. You take this delta 2. If you look at the second forward path, you can see that loop number 3 is not touching. All other loops are touching. So 1 minus L3 we can write. Sorry, L4 in my problem is not touching. Now you got everything. You substitute, you will get the transfer function. Okay, that's what I have done here. Okay, I think that's what exactly I have done. Maybe I have interchanged the loop number. Don't worry about that. That's what finally you will get. Substitute everything, you will get the transfer function. Okay, that's how we can draw signal flow graph and you can find the transfer function. Okay, right. Let us look at another example. This is the example. We can very clearly see that there are 6 signals in this case. X1, X2, X3, X4, X5, X6, X1 to X2. Let me mark this as X1, X2, X3, X4, X5 and X6. X1 to X2. X1 to X2. Gain is 1. X6 to X2. Gain is minus 1. X2 to X3. Gain is G1. X4 to X3. Minus H2. X5 to X3. So minus H3. Feedback. Next X3 to X4. This is G2. Then X6 to X4. X6 to X4. Correct now? Okay. This is X6 to X4 minus H4. Next G3 X4 to X5. G3. Then X5 to X6. Then this is G4. You can introduce a signal of unity gain. Once again, you call it as X6. I think X4 to X3. Oh, this one, I think I made a mistake here. I've taken this as XY, sorry. That X4 to X3. I've done X4 to X3, fine, correct. X5 to X3. Yes, X5 to X3. I think it is correct. Correct. Right. This is minus H3. Okay, done right. Okay, only thing is I have drawn this way, like I flipped here. That's the main thing. How many forward paths are there? Start here, go in this direction. So only one forward path. There are no other forward paths. So T is equal to P1 delta 1 by delta. So what is P1? G1, G2, G3, G4. Delta is 1 minus sum of loop gains of individual loop. Okay. There is one loop here. Okay. There is another loop here. There is another loop here. There is another loop here. There are 4 loops. You can write L1 plus L2 plus L3 plus L4. Okay. Then do we have 2 non-touching loops? There are no 2 non-touching loops, so 0. Delta 1 forward path, if you consider, it is touching all the loops. Forward path is touching all the loops, so 1. So that's what I have done here. P1 delta 1. Substitute, you will get the transfer function. Okay. So this example you can work out yourself. Anyway, I think the solution is given here. Right, so sometimes signal flow graphs will be given. You have to find the transfer function. This is the given signal flow graph. So you can see here, there is one forward path like this. And there is another forward path like this. So there are 2 forward paths. Formula will become like this. Then P1 is path gain of this forward path. G2, G4, G6, G8. Second forward path, G1, G3, G5, G7. You will get delta 1 minus sum of loop gains of individual loops. 1, 2, 3, and 4. Okay. 2 non-touching loops. This and this are not touching. This and this are not touching. This and this are not touching. And this and this are not touching. You will get this. So there are no 3 non-touching loops. Now first forward path, if you consider, let me change the color. If you consider this forward path, these 2 loops are not touching. So 1 minus L3 plus L4. But these 2 are touching loops. That's equal to delta 1. Delta 2. Right. This forward path, if I consider, these 2 loops are not touching. So 1 minus L1 plus L2. Okay. I think that's what I have done here. Then substitute. You'll get a transfer function. Okay. Next, another example. In this example also, signal flow graph is given. This is one forward path. This is another forward path. So k equal to 2. So transfer function is, this is the formula now. P1 path gain of the first forward path, G2, G4, G6, G8, G10. Second forward path, G1, G3, G5, G7, G9. Yes, you got it. Delta 1 minus individual loops. We can clearly see that there's one loop here, one loop here, one loop here, one loop here. So L1 plus L2, L3, L4. Next 2 non-touching. L1 and L2 are not touching. L1 and L3 are not touching. L1 and L4 are not touching. Then L2 and L3 are not touching. Then L2 and L4 are not touching. And 3 and 4 are not touching. Okay, minus 3 non-touching. Yes, 1, 2, 3. L1, L2, L3. Plus 2, 3, 4 are not touching. L2, L3, L4. Oh, any other? 3, 4, 2, 3, 4, 1. That's the thing. L1, L2, L3, one thing. L1, L2, L4. Okay, 3 non-touching. L1, L2, L3. Here I have L1, L2, L3, fine. Then L1, L2, L4. Oh, that is also there. L1, L2, L4. Then L2, L3, L4 we have. Then we have L3, L4, L1 also. L3, L4, L1. Okay. Then we have 4 non-touching. All the 4 are not touching each other. Minus, plus. L1, L2, L3, L4. Yeah, to create this idea only, I formulated this problem like this. Okay, this is what you get. So delta will be a very large value. Delta 1, this forward path, these two loops are not touching, these two are non-touching also. Okay, same. Second forward path, these two loops are not touching and they are non-touching also. So you will get this. Substitute all these things, you will get a transfer function. Got it? Right. Oh, there is another signal flow graph. Let us see how many forward paths are there. Start here. Go like this. Go like this. Go like this. This is one forward path. Start here. Go like this. Go like this. Go like this. This is the third forward path. Then start here. Go like this. Go like this. Go like this. Third forward path. Start here. Go like this. Go like this. This is a fourth forward path. Okay. Start here. Go like this. Go like this. Go like this. Go like this. I'm not crossing node. Go like this. Go like this is one forward path. Next, start here. Go like this. Okay. Then go like this. Go like this. Go this way. Then go like this. This is another forward path. Thus, there are 6 forward paths here. You need to be careful about this. 6 forward paths. So your equation becomes like this. Then find P1, P2, P3, P4, P5, P6. Then find delta. Okay. Right. How many non-touching loops and all. Okay. So what we to find means delta equals 1 minus sum of loop gains of individual loops. This is one loop, L1. This is another loop, L2. Plus let me find out what other loop I have. Okay, start here. See, go like this, go like this, go like this, come back. That is loop 3. Okay, right. Don't think you have any other loops. Plus loop 1 and 2 are not touching. Fine. 1 and these 2 are not touching. You will get delta. Then you can same way you find delta 1, delta 2, delta 3 to delta 4. Then substitute. You will get the answer. Need to be extremely careful by tracing out the paths. Okay. I think you can do it yourself, this problem. Okay. Now, there are two ways when the equations are given how to draw the signal flow graph and find the transfer function I told you. Sometimes when signal flow graphs are given, how to find the transfer function. That also you have learned. In the next session, let us solve some more examples. Okay, till then,